Okay, it's Throwback Thursday, so you're going to take the first few minutes and you're going to do that. I believe this one has about 15 marks on it, so you're going to have about 15 minutes. If you haven't gotten your formula sheets passed out, get those passed out. We'll give you a couple of minutes to look at the quiz to kind of evaluate what you want to do, and then you'll have 15 minutes or whatever the time is for sure to take it. So come back to this when you're done with the PC. Or not the PC, excuse me. The PC is tomorrow when you're done with the Throwback Thursday quiz. All right, so now we've got the normal distribution curve. Do you remember what it looks like? Should look like that. Should be symmetrical. Remember, our mean is at the center, 1 standard deviation away to the left and to the right. Remember sigma, remember mu is our mean, sigma is our standard deviation. We have our mean plus 2 standard deviations, and we have our mean minus 2 standard deviations, and then we have our mean plus 3 standard deviations, and our mean minus 3 standard deviations. And when we get down to here, it's incredibly small. Remember, our percentages here are about 34.13%. Our percent here is about 14 or 13.99%. Our percent here is about 2.15%. And our little bitty tails have about 0.13%. All right, so let's look at some examples. For example, and remember these we'll mostly use our calculator with. So we have heights that are normally distributed with a mean of 170 and a standard deviation of 8. And we want to know what percent fall between 162 and 170. Oops, let me fix that. And this should have a label on it. So we'll say pounds and pounds. Okay. Oops, heights. Sorry. I don't think we're 170 pounds for a height. Let's try centimeters. So what percent fall between 162 and 170? Well, that's 1 standard deviation of the mean, so we should have approximately 34.13%. What percent are less than 154 centimeters? Well, again, think about drawing your picture. Here's my 170. 154 is down here, but that's 2 standard deviations away. So that's my mean minus 2 standard deviations. Going back to this picture, it would be this percent plus this percent. So it would be oops. I want less than that, so I want this piece down here, don't I? okay? Not these two pieces together, but I want less than that, so I want all of this stuff here. So it would be these two being added together. Okay, so it would be these two pieces added together. So that would be approximately 2.28%. Very small amount. Okay. What percent fall between 160 and 180 centimeters? Well, that's not plus or minus 2 standard deviations or plus or minus 3 standard deviations. So that's what we have to do. First of all, we need to make sure we can draw the picture. Here's my 170. One standard deviation would be 178 and 162. So it's going to be a little more than 1 standard deviation away. So we'll say there and there. And we want to know what falls between, so we want these 2%. So remember, one way to do that is to do, since we're doing a cumulative here, we're adding two things, we're going to use our graphing calculator. We're going to use our normal CDF. We need our low, so 160, our high, 180, our standard deviation, our mean, our 170, and our standard deviation, 8. When we put that into our calculator, we get approximately 0.789. So remember, when we're doing these on the calculator, it's normal CDF, and I actually think it's it's on your calculator under that second distribution, and it does spell out the normal CDF. And so it's your lower bound, it's your upper bound, it's your mean, and then your standard deviation. What if we wanted, try this one for me, what if we wanted what percent are less than 150 or greater than, these are two separate ones, not combining them together, greater than 185. Try those two for me, please. All right, so if we look at so pause it here, so you can try that. Can you draw the picture of it? Should be roughly symmetrical. You're going to have to forgive my drawings. Here's 170. Here's 170. Okay, less than 150. So we're talking down here. We're talking less than 150. Greater than 185. We're talking right here. And we're talking all this other stuff. So when we do this here, when we do our normal CDF, okay, what is our lower bound? Well, that's that negative infinity, because it could go to that. So remember, we use 10 to the negative 99 power. Our upper bound is 150, our mean is 170, and our standard deviation is 8. For this one, our lower bound is 185, our upper bound is positive infinity, so we use 10 to the 99th power, our mean is 170, and our standard deviation is 8. Plugging those into our calculator, you should have gotten this one is 0.006 approximately, and this one is 0.030. Okay. Similar example. let's use the same conditions. So a mean of 170, normally distributed. Mean is 170. Standard deviation is 8. And we want to find what value gives us the top 20% of our heights. So here's my 170. Okay. So we want to know, what is this x value here? Where this, that's probably a little close. Let's try to move that over here just a little bit. Oops. We want to know, what is this value when this is 20%? Talk to your side partner about if you remember what to do here. Right, we use the inverse normal. That's also under that second distribution. But remember, that inverse normal measures from here. It measures from 0 up to here, up to this x value. So if this is 20%, what is this? The remaining stuff is 80%. So we need an inverse normal of 0.8, and then we need our standard deviation, our mean, and our standard deviation. When we put that into the calculator, we get approximately 176.7 centimeters. 20% of the population would be 176.7 centimeters or taller. Okay. What if we don't know the mean and the standard deviation, but we want to know these things? Okay, so we don't know the mean and we don't know the standard deviation, but we know that it's normally distributed. Okay, if it's normally distributed and we have this graph, okay, and we know that we're going to go down to the value of negative 0.41 and up to the value of 0.67, and we want to know what percent falls between those. What do we know about a normal distribution? Talk to your side partner about what you know about that. Right. When it's normally distributed, we can say that the mean is 0 and the standard deviation is 1. So you can use that. So you would do your normal CDF. Your lower bound would be your negative 0.41. Your upper bound would be your 0.67. Your mean would be 0, and your standard deviation would be 1. That comes out to be approximately 407. Okay. Do you remember how to find the z-scores? What is the formula for the z-scores? It should be on your formula sheet. So look it up. Okay, so you get z is our x, our value, minus our mean, over our standard deviation. Why do we use z-scores? Because sometimes we have things that have different means and standard deviations, and we want to compare them. Okay? We had an example last year where we had two different scores, and we had the mean on one, that they got a score of 73%. The mean was 68%, and the standard deviation was 10.2%. And then in another class, they got a 66%, but the mean was 62%, and the standard deviation was 6.8%. And we looked at the z-scores for those. So we said the z-score for the first one was that mean, that score value, 73 minus the mean, over 10.2. And we got that approximate z-score of 0.490. For the second set, we had 66 minus 62, excuse me. Over the 6.8. And we got that was approximately 0.588. So then remember we can compare these two. Which class did they do better in if this was their score? They actually did better in this class because they were better than almost 60% of the class. Here they were only better than about 50% of the class. Remember we can also use these scores if we are missing one of those things, if we're missing a mean or missing a standard deviation. So our last example today is we've got a normal distribution with a mean of 20 and 8% of our components have lengths greater than 20.5. And we want to know what is our standard deviation. Remember, if we wanted to know the variance, what would we do to the standard deviation? Right, we'd square it. All right, so let's draw our picture. Okay, so we have a mean of 20. We don't know what our standard deviation is. We know that only 8%, so this little portion here is 0.08, which leaves all of this to be 0.92. Okay. If we do, using these scores, if we do a z-score, we use our mean as 0 and our standard deviation is 1 because we don't know that. And so we do the inverse normal. Of 0.92, because remember we always have to come from the left up. We know normal distribution z-scores have a mean of 0, standard deviation of 1, and we get a z-score of approximately 1.405. Well, how can that then help us find our standard deviation? Well, remember that our z-score is equal to our score minus our mean over our standard deviation. But we know that this is 1.405. We know that our x is 20.5. We know that our mean is 20. And we don't know what our standard deviation is. So solving for standard deviation, we get that the standard deviation is 0.5 over 1.405. When we do that, we get that it's approximately 0.356%, or length, so it's probably centimeters. So remember, if you're missing a component, a z-score is a good thing to go with. Okay, so for tomorrow, I'd like you to do those problems on page 428, numbers 1, F, and G, number 2, E, G, and I, number 3, A, C, G, and I, number 9, number 13, number 19, and number 21. Don't forget you have a PC over the trig and the stats tomorrow, and I'll be back on Monday.